We're going to again use these spectra. We're going to use these spectra and this empirical formula data to identify the compound. Right? Pardon my lost in thoughtness. Okay. So first of all, the mass of each compound from elemental analysis is 30.29. 2.54, and then we don't know. It's got something else in it. It's a halogen, although I can see it's bromine, right? Because I got two peaks there. So the atomic weight, okay, is 12.011. The atomic weight of hydrogen is 0.1 or 1.008. And so the moles of this is, and I'm going to assume there's just one hydrogen atom in it for now. So that'll help us calculate it. 30.29 divided by 12.011 is 2.522. 2.522. 2.54 divided by 1.008 is 2.520. 2.520. And we don't know about that. But I can see this is a 1-to-1 ratio, right? So the molar ratio is 1-to-1. So this is going to be C N H N B R. That's what that's going to be. C N H N B R. So if N is 1, that's the empirical formula. And I got my point for that. Okay. So let's go here now to find out the molecular formula. Well, if N is 1, then it's going to be CHBr, which doesn't make any sense. Let's suppose N maybe is 2, C2H2Br. This could be such a compound could exist. If this were true, then the molecular weight would be 2 times 12 plus 2 times 1 plus bromine, which let's say 79. We'll do the lighter isotope. 24, 26. 26 plus 79 is not 118, right? So let's try 3. 3 times 12 plus 3 plus 79 is equal to 36 plus 3 plus 79 is 39 plus 79, which is 118. Okay, so it looks like the molecular formula then is C3H3Br. This is going to be, this is going to be complicated. All right, so, well, we don't have any possible constitutional isomers, but that's weird, okay? So we're going to say that's the M plus peak. And now I have my 1 point for that, okay? Let's move on to the next goal is to write out all the constitutional isomers. Okay, so what's the, I don't want that. I want this, boom. Okay, all the constitutional isomers. And they are going to be C, 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 C3. Okay, so if this were saturated, it would be C3H8. Is that right? Yeah, C3H8. But it's or C3H. Yeah, C3H8. Not counting the halogen. Remember, halogens take the place of one hydrogen, right? So this is like C3H4. So we've got 2 degrees of unsaturation. HDI is equal to 2. That means we either have 2 double bonds, right? Or a triple bond, right? Or a double bond in a ring. Okay? Well, we're not going to consider double bonds with rings. It's really highly unusual. This is super, super unstable. So I'm not gonna even consider that because it's you see that ring strain right there, so tight, and it makes it even worse that it's a double bond. Super unstable, bad, probably explosive, right? Because that ring strain, we just don't see that. So let's consider these 2 possibilities, and now the possibilities include. I admit I'm looking over for clues. You just caught myself looking over here for clues. If we had a double bond, we probably would have a doublet over here, right? It's a triple bond, so this looks like a carbon-carbon triple bond. I admit I cheated when I looked over there for that. Okay, so I'm going to assume for now it's a carbon-carbon triple bond. If things don't work out with the conclusion, then we'll go from there. Okay, so let's assume we've got that. So it's either that with a hydrogen over here, right? 2 hydrogens there and 1 here, or it's Br with the 3 hydrogens here, right? So I can see from looking at my IR spectrum that I've got 1 and 2. Okay, so this is more likely. This is unlikely. Actually, the NMR spectrum tells me it's not that. Okay, so this is likely the spec. And I've just got my point for constitutional isomers, and I've also narrowed it down substantially. I haven't narrowed it down from this yet. Let's go back up here. There's 2 hydrogens there, and a hydrogen and a bromine here. So yeah, it could be this. Okay, could be this, but I'm pretty sure it's not. I'll look in my IR spectrum table for a triple bond, but I think we're going to get something right there. That's what I think we're going to get. Okay, so I'm going to move ahead as if it's this one. Maybe no, I'm going to go look at my IR spectrum now because I'm going to forget to come back to that because I'm not sure that there's any. I'm going to chapter 14. These are tables that you have, IR tables that you have for your exams, right? You don't memorize these. I'm looking for IR spec. Okay, I'm looking on page 619 of the David Klein text. It's the 3rd edition on page 619, and I'm looking for a triple bond. You know what? This is exactly what it is right there. It is not the, but it wasn't the triple bond. Sorry, it was the carbon. It was the hydrogen, carbon hydrogen. I should have known that, right? It was sp hybridized, right? That's right there at. And my text says 3,300, and look at that. Boom. Wow. Okay. So that's good evidence that this is a triple bond. And so now I'm going to come down. I'm going to assume that this is my structure. Okay, I'm going to assume this is the structure. I'm going to call this atom A, or hydrogen A, and these 2 hydrogen B. Okay, so type, number, n plus 1, and shift. This really helps, right, to make predictions in advance, A and B. How many are A? There's only one that's A. Likely that one, right? 0 neighbors, so it should be a singlet. And it's shift. Now, looking on page 66, or 666, looking on page 666, for a triple bond, a hydrogen on a triple bond, and it says it's about 2.5. Shift is about 2.5. And you see I'm training my eyes. I'm basically looking at the horizon there. I'm looking for 2.5 and I'm going, yeah, that's definitely it. Right? That's right on that. Okay? It's slightly under. Okay? So the next one then is going to be 2 hydrogens that are next to a triple bond are also next to a halogen. So this says 2 to 4 here. Yeah, right next to a halogen. The hydrogen's right next to a halogen. It says anywhere from 2 to 4. Okay? There are 2 of them with 0 neighbors, and so it should be a singlet. Is this believably a singlet? Sure. Sure it is. Yeah. Funny enough, these 2 hydrogens, this would be, these 2, what do they call it, diastereotopic? No, they're enantiotopic hydrogens, right? They're actually not identical. So they do split each other a little bit, and they're right there. So, yeah. I hope that's right. Whoever someone watching the video really knows is going to call me on it, get really mad if I'm wrong. So, all right. So far so good. Let me erase that because that was the last point. Let me come here and say I got my 1 out of 1 for my prediction. Okay. And then my final assignment here is to assign them. So definitely that is hydrogen 1 or hydrogen A, and here's hydrogen B. And we know the structure. Okay. If you don't like that, maybe you should go back up to this one with 2 double bonds on it, and see if you get similar, if you can get similar evidences, okay, of similar quality. But that's good. I'm certain that that's the structure, and I'm going to get full credit for it. Oh, 1 point for that too. Okay, I'm not going to say anything about carbon-13 spectrum. All right, hope that's helpful.